In this class, straight away we go for direct form 1 realization structure, right? As I told you, hope the screen is visible to you now. As I told you, this is the general form of representation of any difference equation, any IAR filter. It will always be represented with the help of a difference equation like this. This is of order n. Here n is equal to m. Okay. And this IAR filters are recursive in nature, which means the output can be computed only in order. The output at any time instant, it depends on the past outputs also. So it can be computed only in order. Okay. So this is the general difference equation, and this equation must be known to you thoroughly. Okay. And if you come to this structures of IAR, as you know, there are 4 different types. One is direct form 1, 2, cascade form, and parallel form. And as I told you earlier, there are 3 basic elements that are required to draw the structure of any filter. Both IAR as well as FIR filter require 3 basic hardware elements, and those 3 basic hardware elements are block diagram elements used in the block diagram are this adder, okay, adder, multiplier, and delay element. Delay element will be represented as Z inverse. So if x of n is being passed through this delay, the output is delayed by 1 unit. This is called unit delay element. It is called unit delay element. So the input will be delayed by 1 unit in time. So x of n, as it enters the delay, output will be x of n minus 1. Multiplier, you know, it will multiply the given input. So this is x of n into a, output will be a into x of n. And this is nothing but a summer adder. So this is a 2-mark question, which is what are the basic elements of a block diagram? Basic elements of block diagram. You have to write these 3: adder, multiplier, and unit delay. These are the 3 basic elements of a block diagram. Okay. We'll move on to direct form 1 structure realization. So as we know, any LTI system or any filter will be described by with the help of difference equation. So this is the general difference equation that is available. Okay. Now, if we expand this difference equation, for different values of k from 1 to n for this and for 0 to m for this, we will get an equation like this. Is it not? Now we are expanding this term. So it is minus a1 y of n minus 1. You will get the first term to be this, and minus a2 y of n minus 2 till last term will be minus an y of n minus n, capital N, plus you have another summation to be expanded where k starts from 0. So if I substitute k 0 here, this is b naught x of n plus b1 x of n minus 1 you will get, plus etc. till the last term will be bm x of n minus m. This is the last term. Now once this equation is expanded, so you will be in the problem if you are asked to draw the structure of direct form 1 for any given difference equation. In the problem, they will give a difference equation like this for different values of n and m. They will give an equation like this. And the step that you have to follow is, the very first step that you have to do is, you will be given a difference equation in the problem. In the first step, you have to consider all these input terms. That is, we are going to separate all these input terms. Input terms are nothing but terms with x. So all these input terms alone we are taking from this equation and we are equating it to w of n. This is the first step that you have to do. Is it clear? B naught plus B1 plus B2, all these B terms alone we are taking and we are equating it to w of n. So let w of n is equal to all the input terms. This is the first step that you have to do. Okay. And once this is done, next in the next step, we have to express this y of n in terms of w of n. Now w of n is nothing but all the input terms. So now y of n can be expressed in terms of w of n like this. All the past output terms we are writing as such. All these terms we are writing as such, plus instead of all these input terms, now since we have equated it to w of n, we can simply write plus w of n. Is it clear? So this is the two steps that you have to follow in direct form 1 realization structure. You will be given a difference equation. Okay. Once the difference equation is given, you group all the input terms and equate it to w of n. This is the first equation. This is the first step. Once you write this, then you represent this w of n, this y of n in terms of w of n. So all past outputs plus you will get w of n. You can consider this itself as equation number 2 and this as equation number 1. From these two equations, we can go for the realization structure directly. We can very well draw the structure. Okay. Or in other words, we can take Z transform of these two equations and go for realization structure. For these two equations, if we take Z transform, we are going to get this particular equation. That is for equation number 2. This equation, if you take Z transform, it is y of Z. Y of n, Z transform is y of Z minus a1 we are writing as such. What is Z transform of y of n minus 1? Hope you remember this. Z transform of y of n minus 1. This is time shifting property. For finding the Z transform of any input or output like this, which is shifted in time by 1 units or 2 units or k units in general, you have to apply the time shifting property of Z transform to solve this. And it can be reduced very well as Z inverse y of Z. Hope you remember this. Whatever the value you are getting here, it is Z power that value. If suppose in general, if it is n minus k, this will be Z power minus k y of Z. So if I take Z transform for y of n minus 1, it will be Z inverse y of Z. For y of n minus 2, it will be Z power minus 2 y of Z. Likewise, for y of n minus n, it will be Z power minus n y of Z. Plus for w of n, it is w of Z. Likewise, they have taken the Z transform for the first equation also, which is w of z is equal to b naught x of z, b1 z inverse x of z plus b2 z power minus 2 x of z. Using any of these two set of equations, either equations 1 and 2 can be taken directly, and from this equation 1 and 2 itself we can go for the drawing of realization structures, or sometimes you can make use of this transformed equations also. Okay, now using this equations 1 and 2, we can very well draw the realization structure. Let us see how to draw the realization structure. Okay, so the same equation I have represented here. This is the general difference equation. We have expanded it. This summation I have expanded and it is written in the bracket. And this summation also we have expanded and it is written here. Okay. Now, as I told you in the first step, you have to group all the input terms and equate it to W of n. So we have taken only this input terms and we have equated into W of n. And in the second step, we are representing Y of n in terms of W of n. So Y of n will be the first past output terms plus W of n. So these are the two equations. And as I told you, directly for direct form 1 structure, from this difference equation itself, we can draw the structure. Let's see how to draw the structure. Now, first, let us consider this equation 1. We are going to draw the structure for this equation 1. And for drawing the structure, hardware structure of this equation 1, as we know, the hardware elements that we require are, we need some multiplier because there is multiplication involved here. Also, we require an adder. Summation operation is here. And then you require delay element also. Delaying is also been done here. So let us see the structure for equation 1. Just listen. Later on you can draw. structure of equation 1. Right? See, consider equation 1. Draw a line. For this equation 1, x of n is the input and w of n is the output. Look at this. X of n is the input and w of n is the output. Okay. So initially I am writing the inputs and outputs. X of n is the input and w of n is the output. Okay. Now, what is the first term? The first term is b naught x of n, which means x of n must be multiplied with this constant b naught. Okay. So this is x of n. This x of n now must be multiplied with the constant which is b naught. For multiplier, for indicating multiplier, we can very well use this triangle symbol. But instead of using the symbol directly also, we can put an arrow mark and place this constant here. It means also it is a multiplier. If you want to draw it perfectly, you can very well make use of a triangular box here and indicate b naught inside this triangle. Okay. So this is b naught. B naught into x of n. So to this point, what I will get? At this point, I will get b naught multiplied with x of n. This term is over. We have represented this term. What is the next term? Next term is b1 x of n minus 1, which means x of n. Yes? Any doubt in this? X of n must be delayed by 1 unit of time. This is the mathematical operation that is involved, right? If I want to draw the structure for the second term, it has x of n minus 1. So I will get this x of n minus 1 if x of n is delayed by 1 unit of time. After delaying x of n by 1 unit, this has to be multiplied with b1 to get this term b1 x of n minus 1. So how that can be realized? X of n must be delayed by 1 unit. So we are passing x of n through a unit delay element. So at this point, after passing through this delay, I will get it as x of n minus 1. In terms of z transform, if I express it, this will be x of z. Output of this will be z inverse x of z. Okay. So now this is delayed by 1 unit. With this delayed x of n, we have to multiply b1. So at this point, we will get b1 into x of n minus 1, which is nothing but the second term. After forming the second term, as per this equation, the second term must be added with the first term. This 2 has to be added. So how that can be expressed with the help of a adder? See, this is b1 x of n minus 1 and this is b naught x of n straight away coming here. So these two, if I put an arrow mark here like this, in this direction, this signal will get added with this signal. So first two terms we have drawn the structure. What will be the next term? Next term is z power minus 2. Sorry. Next term will be b2 x of n minus 2. So x of n must be delayed by 2 units of time. So again you pass this x of n minus 1 by another delay element. You will get x of n minus 2 because now it is delayed here once and then second time it is delayed while it has been passing through this. Okay. So once it is passed through 2 delay elements, we will get the result as x of n minus 2 and now this will be multiplied with b2 and this has to be added with the previous term. Like this, it will extend. This is the general structure, so it will extend. Last term will be, again, it is Z inverse. Now this will be passed through BM, that is multiplied with BM, and it will be added with the previous term. This is the structure of equation 1. As per the equation, we have drawn the structure using the 3 basic block diagram elements: adder, multiplier, and the delay element. Okay. Now, once this structure is over, equation 1 structure is over, you have to go for the structure of equation 2. I am drawing it to the side of this. If I draw the structure of equation 2, if you consider this, for this structure, we can take W of n as input, Y of n is the output. Y of n is the output. Okay. Now, if I want to draw the structure, let me take the first element in this equation. It is minus a1 y of n minus 1. So what I have to do? We have to delay this y of n by 1 unit, multiply it with minus a1. Okay, you will get the first term. So y of n is passed through a delay element. It's very simple. All the realization structures are very simple. You will get y of n minus 1. Now this must be multiplied with minus a1. Minus a1 you have here, right? And this term must be added with w of n. This term must be, all these terms must be added with w of n finally. Here we have w of n. So add it with w of n by including an adder. Okay, place the arrow mark here. The direction of the arrow mark is very important. This is how the structure goes. Second term is was what? Minus a2 y of n minus 2. So again you pass this through another delay element to get y of n minus 2. This is y of n minus 2. Multiply this with minus a2. This has to be added to the previous term. Add it with the previous term. Like this it goes, and the last term will be Z inverse. You will get y of n minus capital N. This will be multiplied with minus an, and it will be added with the previous term. Right? Now this is the structure for equation 2. Then you cascade these two structures. You combine these two structures. Output of the first equation must be given as input to the second equation, because second structure, because the output here is given as input to this equation 2. So just cascade it, connect it in series. This is the combined structure of direct form 1. This is how you have to form, or you have to draw direct form 1 structure.